Now in example 2, we need to write an equation of a line, again, that passes through a given point, 1, 5, and is parallel to this given line, 5 plus y equals 3x. Now, this is a little different than example 1. In example 1, we were given a line that was already in slope-intercept form, so it was really easy to identify what the slope was. Now, if you compare that to example 2, the equation of the line that's given is not in slope-intercept form, and it's not in point-slope form either. So what we need to do before we identify any information is we need to get the given line and put it into, put the equation into slope-intercept form, and the way we will do that is by solving for the variable y. Because if you noticed from the equation, when you have slope-intercept form, the y is all by itself on the left-hand side of the equation, or the equal sign. So going back to this example, I'll copy down the equation again. I'll write 5 plus y equals 3x. So all we need to do is get y by itself, and this is pretty simple. All we have to do is get rid of the addition of 5 that's going on. So if we subtract 5 from both sides, 5 minus 5 goes away, so now we're left with y by itself, which is what we wanted. On the right-hand side, 3x and 5 are not like terms, so you can't really take 5 away from 3x. You would just write the right-hand side as 3x minus 5, and that's it. So now we have the given line in slope-intercept form, and now we can really easily identify what the slope is. So if we want to write an equation of a line that's parallel to this line, we know the slope of that line has to be the same, which is 3. So that made our lives a little easier. So we know the slope has to be 3. So let's go ahead and graph the given line. The given line has, again, a y-intercept of -5. That's our b, and that's our slope. So a y-intercept of 1, 2, 3, 4, 5, and a slope of 3. So 1, 2, 3 up 1. 1, 2, 3 up 1, 1, 2, 3 over 1. Okay, so this is our given line, and we need to find the equation of the line that's parallel to this line, and it has to pass through the point 1, 5. So now we're going to turn to our point slope equation, y minus y1 equals m times x minus x1, and we're going to plug in the stuff that we know. Well, we know the slope has to be 3 because it has to be the same as the slope of the given line. And we know that our x1 is 1 and our y1 is 5. So plugging that all in, we have y minus 5 equals 3 times x minus 1. Now I could put this down here and I could say that the equation of the line that is parallel to the given line that goes through the given point is y minus 5 equals 3 times x minus 1. However, remember here the question asks for the y-intercept. I cannot tell what the y-intercept is by looking at the point slope form. Remember that you can only really easily see what the y-intercept is by looking at the slope-intercept form. The point-slope form doesn't easily tell us anything about the y-intercept. Now remember from the front page how I turned, or I'm sorry, not from the front page, from the first example, how I turned the point-slope form into the slope-intercept form. So let's do that again. So let's solve for y. So distribute the 3. So now I have y minus 5 equals 3x minus 3. And then I'm going to add 5 to both sides, giving me y equals 3x plus 2. So I could say the equation of the line is the blue one listed here, and that's point slope form. Or I could say that the equation of the line is 3x plus 2, and that's the slope-intercept form. So I know the y-intercept would be 0, 2. Going to my graph, I'll go to the y-intercept of 2 and a slope of 3. Rise up 3 over 1, or I could rise down 3 to the left 1. And connecting all of those points, I now have drawn the equation of the line that runs through the given point. If you want to check the point 1, 5, 1, 1, 2, 3, 4, 5, it's right here. So the line does go through the point that was given to me, and it's parallel to the equation of the line that was also given. So that covers writing equations of parallel lines. Flipping to the next page, let's focus on writing equations of perpendicular lines. So example 3 wants us to write an equation of the line that passes through the given point, -2, 5, which is right here. And we want this line to be perpendicular to the line y equals 2x plus 1. Now, we're given this line, y equals 2x plus 1. That's in slope-intercept form. So the slope is 2, the y-intercept is 1. So the line looks like this. That's the line that's given to us. And we want to draw a line, or we want to find the equation of the line that's perpendicular and runs through this point. So right now, if the slope of the line that's given is 2, we have to ask ourselves, okay, well, if the slope of the line that's given is 2, what would be the slope of the line that's perpendicular to that? Now remember, perpendicular slopes are always going to be opposite reciprocal. Opposite reciprocal. So right now, if the slope is 2, and 2, keep in mind, 2 can be written as 2 over 1. It's a whole number. Opposite means that since it was originally positive, it's going to become negative. And reciprocal means that you flip the numerator and the denominator. So the opposite reciprocal slope, the slope of the perpendicular line, is going to be -1/2. So writing this in an equation, since we know the point and now we know the slope, we can say, okay, the x1, y1 is -2, 5, and the slope is going to be -1/2. So writing that in point slope form is going to be y minus 5 equals -1/2 x minus a -2, which becomes a +2. And they ask us for the y-intercept. Again, you can't see what the y-intercept is, although this is a valid equation of the line, so I'm going to go ahead and put it down here. But there is another form, and remember what that other form is that is slope-intercept. So if I want to find the slope-intercept form, remember all you have to do is solve for y. Oops. So by solving for y, we're going to distribute that -1/2. So we're going to have y minus 5 equals -1/2 x. -1/2 times 2 is -1. Adding 5 to both sides. I'm running out of room. I'm going to draw a little arrow. That goes away. I'm going to have y equals -1/2 x. -1 plus 5 is +4. So the other possible equation of my line is that y equals -1/2 x plus 4. Either one is a valid form or a valid equation for the line that is going to be perpendicular to the line that was given to us. So let's go ahead and graph this. So starting up here at a y-intercept of 4, 1, 2, 3, 4, I go up 1 to the left 2, and that brings me to the point -2, 5. Go up 1 to the left 2, up 1 to the left 2. I can also go down 1 to the right 2, down 1 to the right 2, so on and so forth, connecting my dots. gets me my line, and as you can see, that line, although you can't just assume because it looks perpendicular, but since we actually did the calculations, we know that it's for sure perpendicular, and this red line is perpendicular to our given line, y equals 2x plus 1. And then lastly, don't forget to fill out the y-intercept. The y-intercept is 0, 4, and we saw that from finding the y-intercept form of the equation by solving for y. And we saw that the b was 4, positive 4. So moving to example 4 is going to be very similar as examples 1, 2, and 3 that we just did. We have to find the equation of the line that passes through the point 2, 3, which is right here. And the line has to be perpendicular to this given line. But if you notice, look at the line that's given. It's not in slope-intercept form. So we need to first turn it into slope-intercept form, y equals mx plus b. So if I've got 2x plus y equals 2, solve for y. Subtract 2x, subtract 2x. That goes away. I have y equals negative 2x plus 2. Now, it's easy for me to see that, okay, my slope is negative 2. Now, if I want to know the perpendicular slope, that's opposite reciprocal. So the opposite would be positive and reciprocal would be 1/2. You can't see that well. Let me rewrite that. 1/2. So if I know this is the point, I know the slope has to be positive 1/2. So I can go up 1 over 2. I could go down 1 over 2, down 1 over 2. And it's really nice and convenient that I have a really nice and clear y-intercept here. My y-intercept is 0, 2. Remember that the original line, I never graphed it, but the original line was 3. So the original line I never graphed, that also had a y-intercept of 2, but the slope was negative 2. So if I rise up 2, I would go left 1, and if I went down 2, I would go right 1, and so on and so forth. And you can clearly see that these lines are perpendicular. They form a 90-degree angle. So, back to the question of saying, well, how would we write the equation of this line that was perpendicular to our given line? So you have two options. You can either choose the point-slope form. The point-slope form, remember, is y minus y1 equals m times x minus x1. Or you can do the slope-intercept form. And remember, the slope-intercept form was y equals mx plus b. I will save that process of writing the equation of that line that's perpendicular in both point-slope and slope-intercept form, and go ahead and write that on the line down below. When you're finished doing that, try the geometry connection and extension on the last page of these notes.